Okay, hi guys. So in this lecture, we'll be seeing test for phenol. Okay, so let's get started. So test for phenol. So first, before going towards that, just let me write the acidic order of the following compounds. So suppose we have RCO2H. It is actually more acidic than carbonic acid, which is actually more acidic than PHOH, which is similar to, and these all compounds have the similar acidic strength, RNH3 plus, and we have this compound as well. Okay, so which ROH is actually less acidic than all these compounds. Then comes alkyne. Okay, so just remember this sequence. So some notes here that sodium bicarbonate is used to separate a binary mixture of benzoic acid and phenol. Okay, we will see the reaction in a short while, but I'm just writing the notes first that sodium bicarbonate is used to separate a binary mixture of benzoic acid and phenol. Okay, second point is that sodium bicarbonate will not react with phenol because carbonic acid is stronger acid than phenol. Sodium bicarbonate will not react with phenol because carbonic acid is a stronger acid than phenol. Okay, so let's now look at the reaction of these two compounds with sodium bicarbonate, NaHCO3, and let's see what is the product formed after the reaction. So it is used for separation of binary mixture. We'll just see the reaction in a few seconds. Okay, so now we have something like PHCO2H and we have phenol. Okay, so when these two compounds undergo, the solution actually undergoes the reaction with NaHCO3, so we'll get that the acid actually forms or actually reacts with NaHCO3. Okay, and get carbonic acid in which CO2 gas is released. Okay, and this is actually soluble. Okay, and on reaction with H plus we get again CO2H, hence CO2H is separated out from the mixture, and phenol is, which is insoluble, gets insoluble into the mixture, we can separate it out. Okay, hence we separated out the mixture. Okay, let's look at another example where we have a mixture of aniline and phenol. So when we pass it through concentrated HCl, what actually happens there is in concentrated HCl, NS2 will behave as a base. Okay, and nitrobenzene, sorry, this is not a phenol, this is nitrobenzene. Okay, nitrobenzene will separate out from the mixture again. So how will you separate a mixture of carboxylic acid, phenol, aniline, this is benzene carboxylic acid obviously, and NO2. Okay, so what is the step of reaction we are going to take? So in the first step, if you take NaCO3, obviously PHCO2 minus would be separated out from the rest of the mixture, which is phenol, aniline and nitrobenzene. Okay, in the second step what you will take is, we are left with these compounds. Okay, so in the second step you take NaOH, which will separate out phenol. Okay, and rest we get something like which are not separated out is aniline and nitrobenzene. Next what you will take is, in the third step you can take HNO3. Okay, HNO3 will separate out aniline and NO2. Hence all the compounds are separated out, first carboxylic acid, then phenol, then aniline. Okay, let's take another example. We have, what happens when we react the benzene sulfonic acid with NaHCO3. Suppose we get A gas. Now what happens when we react NO2 here, OH in presence of again NaHCO3, we get B gas. Okay, so you have to tell or output the sum of molecular mass. So for A plus B you have to output, so A gas would obviously be CO2, because carbonic acid would be formed and as a result CO2 would be evolved. And in the second case again carbonic acid would be formed as a result CO2 would be evolved. So 44 plus 44 gives me 88, which is the answer. Let's look at the last example for this video lecture. So we have acid on reaction with NaH14CO3 and we have again pH 14 C double bond O OH and NaHCO3. This evolves A gas, this evolves B gas. Here to output the sum of molecular masses of A and B. So we will be getting A plus B equals to 90. How? A gas would be obviously CO2, in which C14O2, and in this case CO2 would be evolved. Why? Because in this case CH-C14O2, or rather I should write 14 in the superscript. Just a second. So we'll get C14O2 here, and here we'll be getting H2CO3. Okay, so 90 would be the answer. So with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the evolution of gas when organic compound reacts with different reagents, and then we'll be seeing haloform reaction. So till then, good luck and goodbye.